Hello and welcome back. These would be the notes for Chapter 7, Section 4, Solving Systems by Multiplying First. There is a PDF that you can print out and follow along if you'd like to do so. Now, solving systems by multiplying first is really a fancy way of saying find a least common multiple. So if you remember in the previous section, we would use elimination, but elimination would only work if I have coefficients that are the same. Well, you see here for my x's and my y's, I don't have common coefficients. However, I can turn this 2 into a 6 by multiplying this second equation by 2. But I'm going to distribute that 2 all the way across. So the first thing I'm going to do is bring my original equation on top, 6x plus 5y equals 19 over. Then as I distribute my 3, I'm going to write my answers underneath. So 2x times 3 gives me 6x plus 3y times 3 is 9y equals, and then 3 times the 5 gives me 15. And now that I have a common coefficient on my x's, my decision is how do I get a positive x or a positive 6 to cancel out? Well, I have to subtract. Remember, you have to put a parentheses around your subtraction here. So 6 minus 6x gives you 0 x's. Those cancel out. 5 minus 9y gives you a negative 4y. That's going to equal 19 minus 15, which is positive 4. Divide both sides by negative 4, and you get a negative 1 for y. Now keep in mind that this is a system, which means I have to have two solutions. My y coordinate is negative 1. I now have to solve for x. My recommendation is to go back to one of your original equations to solve for x, not one of your altered equations. I'm going to use this one right here. So 2x plus 3, and in place of y, we're going to substitute the 1, and then calculate the value of x. So 2x is going to be subtracting with 3, because 3 times negative 1 is negative 3, so minus 3 instead of plus negative is equal to 5. Move the 3 over, add 3 to both sides, you get 8. X then would equal 4. So the other half of your solution is 4. So the solution to our system is 4, negative 1. Example 2, sometimes we have a situation where the variables are not lined up like you see here. So the first thing I want to do is line up my variables. So this first one does not need to be altered because it's already in standard form. Standard form is one of the easiest ways to do this. I'm going to move my 5x this way, which will give me a negative 5x, a positive 9y, and a positive 5 still left over on that side. Now you'll notice though that 3 and 5 are not multiples of each other, nor are 9 and 7. So I can either get a common coefficient on the x's, or I can get a common coefficient on the y's. I'm going to choose the x's because they're smaller to work with. What that means is I got to think of my least common multiple of 3 and 5, and that would be a 15. So how do I make this 3 turn into a 15? Well, I have to multiply everything by 5. So how do I make this negative 5 turn into a 15? I got to multiply everything by 3. So I'm going to end up getting two new equations. So my first one is going to be 5 times 3 is 15x. 5 times a negative 7 is negative 35y. And 5 times 5 is 25. And distribute my 3. 3 times negative 5 is negative 15x. 3 times 9 is positive 27y, and 3 times 5 is 15. Now that I have my x's with a common coefficient, how do I get a positive and negative cancel out? I'm going to add. So 15 plus a negative 15 gives me 0, so this cancels out. And then a negative 35 plus a positive 27 ends up giving me a negative 8y. And 25 plus 15 ends up giving me 40. Divide both sides by negative 8. And y ends up equaling a negative 5. Now again, this is a system of equations, so I only have half of the answer here. So I have a negative 5 for y. I got to calculate my x value. So I've got to choose one of my original equations. I'm going to choose this equation right here to substitute in. So 3x minus 7 times, in place of y, we're going to substitute a negative 5. And that's got to equal positive 5. 3x is going to equal positive 35, which equals plus 35, which equals 5. Move the 35 over, so x is going to equal a negative 30. 3x is going to equal negative 30 divided by 3 on both sides, and x equals negative 10. So our final solution here is negative 10, negative 5, and that is the solution to the system. Example 3. A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and two soccer bags for $155. Another coach purchases 12 soccer balls and 3 bags for $189. They want to know the cost of the soccer ball and the cost of the bag. So cost of the soccer ball and the cost of the bag. So I'm going to use two variables, x and y. And let's call the first x. They're telling us find the cost. So it's going to be the cost of soccer ball. That's one soccer ball. And y is going to be the cost of one soccer bag. So I've got x and y. First coach, it says purchase 10 soccer balls. So 10 times x is the cost of those soccer balls, plus 2 soccer bags, 2 times y, is going to equal $155. And the second coach came in and bought 12 of the soccer balls and bought 3 of the bags and spent $189. And there's our two equations. So quite often when we can write our equations in standard form, solving becomes quite easy. Now, you'll notice that I don't have common coefficients on either x or y, but it'd be easy to cancel out the y values if I can get them to become common coefficients. And what that means I got to do is find the least common multiple of 2 and 3. So that makes a 6. So if I multiply the top one by 3 and the bottom one by 2, my y's will now have a coefficient of 6. So make sure you use a calculator when doing this. So 3 times the 10 gives you 30x, plus 3 times 2 gives you 6y, and 155 times 3 gives you $465. Do the same thing on the second one. Distribute here. 2 times the 12 gives you 24x, plus we're going to have 6y. That's what we intended. And 189 times 2 is going to give you $378. And now I have positive y values of 6. So how do you get them to cancel out? Well, you have to subtract. So 30x's minus 24x's leaves you with 6x's. We know the y's are going to cancel out. 465 minus 378 is going to give you 87. Divide both sides by 6. And you get a cost for x of $14. Now, the answer on my calculator comes out to 14.5, but we're talking about money, so it's $14.50. Now, keep in mind, the cost of x is the cost of the soccer ball itself. So the soccer ball cost, the ball cost $14.50. And then the bag is the only unknown remaining. So how do we calculate that? Take our $14.50 and let's plug it into this equation up here. So 10 times 1450 plus 2y is equal to 155. So 10 times 1450 is 145 plus 2y equals 155. So 155 minus 145 ends up with 10. So divide by 2 on both sides, and you have a cost of the soccer bag of only $5. Example 4, book sale. A library is having a book sale to raise money. Hardcover books cost $4 each. Paperback books cost $2 each. A person spends $26 for 8 books. How many hardcover books did she purchase? So the question is how many hardcover books. So I'm going to use H for number of hardcover, and I'm going to use P for number of paperbacks, and that's how many of each. They did say that we bought 8 books. Well, number of hardcover plus number of paperbacks has to equal 8 books. There's our first equation. We also know that the total cost of the books was $26. Well, how do you find the cost of the hardcovers? Well, they cost $4 each. So for H plus $2 times the number of paperbacks equals $26. In order to cancel or use the elimination, we have to multiply first. So we have to make a decision. Do I want to cancel out the number of paperbacks or the number of hardbacks? Now, we are only asking you to solve for the number of hardbacks. So we want the letter H to be left in the problem. So what we should eliminate is the letter P. So how do I get the P and the 2P to become common? Well, I only have to multiply the top one by 2. So I distribute here, I get 2H. I distribute here, I get 2P. I distribute here, and I get 16. So this is my new equation. So how do I get a positive P, 2P to cancel out? We have to subtract. So 4 minus 2 gives us 2H. 2P minus 2P leaves you with 0. And 26 minus 16 leaves you with 10. So divide by 2 on both sides. H equals 5, and that stands for the number of books. Now, since they were only asking for the number of hardcovers, we wanted to leave the letter H in the problem so I don't have to go back and solve for the number of paperbacks. But that's pretty easy to figure out because we had 8 total books. 5 of them were hardbacks, therefore the other 3 were the paperbacks.